So in one of my previous videos, I showed that there's kind of a formula for squaring binomials or multiplying binomials in the form a plus b and a minus b, right? So when we're factoring, we could just use this concept and reverse it. So it's very important to be able to recognize these patterns. So let's look at this first one over here, and try it on your own. Pause the video, try it on your own if you want. So let's get into it. So 4x squared plus 12x y squared plus 9y to the fourth. Okay. So let's try to figure out something. So we know that it's definitely not the difference of squares that I've talked about, like a plus b times a minus b, but it could be squaring a binomial. So it could be in the form a squared plus 2ab plus b squared. Okay, well, let's try to prove this. So let's figure out, so we know that the first and last term are squared, so let's unsquare them. So 4x squared. So what's the square root of 4x squared? Well, the square root of 4 is 2, and the square root of x squared is x, okay? Now let's look at the last one. 9y to the fourth. So what's the square root of 9? That's 3. What's the square root of 9 to the fourth? That is y squared. So let's try to see if this is 12xy squared is equal to 2 times ab. So it's gonna, what's 2 times a, which we found is 2x, and times b, which we figured out is 3y squared. That's supposed to be a 2, okay? Just ignore that. So let's multiply that. So 2 times 2 times 3, that's 4 times 3, that's 12, times x times y squared. And look at that. Those match. So if it's in the form of a plus b squared, then we know that 4x squared plus 12xy squared plus 9y to the fourth is equal to 2x plus 3y squared. Or if you wanted to, here, let me erase it. If you wanted to, times 2x plus 3y. You can write it either way. It might be a little easier to write it like this. Okay, so now let's work on this other one. So, right off the bat, we can see that there's two perfect squares, 25 and 16. So, maybe it could be written in the form, or at least it could be the result of a plus b times a minus b, which we know is equal to a squared minus b squared. So, to figure out what a and b are, let's find the square roots of each term, okay? So 25x to the sixth. So what's the square root of 25? It's 5, right? And the square root of x to the sixth is x to the third, okay? Now, what's the square root of 16? That's 4, and the square root of y to the fourth is y to the second, okay? So that works out. So if we know what our a is, and we know what our b is, we know that 25x to the sixth minus 6xy to the fourth is equal to 5x to the third plus 4y to the second times 5x to the third minus 4y to the second, okay? Another thing I learned is called polynomial identities. I'm not really going to talk about it because it's kind of just proving equations with polynomials using algebra. It may sound complex at first, but if you have a good understanding of algebra, it's pretty easy. If you want to learn more, curious, check out Khan Academy, and they have a few videos on that. We're talking about geometric series. So what's a geometric series? Well, a geometric series is basically the sum of an infinite number of terms that follow a common ratio. So let me give you one example. So we have 5, 10, 20, 40. So most of us can easily see that it's just going in jumps, right? So it follows a common ratio, and it's basically just multiplying by 2 each time, right? But what this really means is you take your base 5, and then the next term is going to be 5 times 2 to the first. Then the next term is 5 times 2 to the second. And the fourth term is 5 times 2 to the third. So you're basically just multiplying your first number, your first term, by 2 to the power of 1 less than the term you're on, okay? So it follows a pattern. And there's a formula to be able to figure out the sum of a certain amount of terms in a geometric sequence. So the formula is a times 1 minus r to the n divided by 1 minus r. And if you want to learn the proof behind this formula, I suggest check out Khan Academy, where they have a video showing how and why this formula works. And so a, the term a means it stands for the first term of the sequence. R is for the common ratio, and n is the number of terms that you want. The number of terms that you want to sum. Okay. So let's give an example. How about we do 3, 9, 27, and 81. So 3, 9, 27, 81. Okay. Well, as we can tell, the common ratio is multiplying by 3, right? Because 3 times 3 is 9, 9 times 3 27, 27 times 3 is 81, okay? So we know our first term, and how about we can do what is the sum, that was a bad signal or sum sign, okay, of the first 10 terms, okay? First 10 terms, okay? Well, how do we figure this out? Well, we basically just plug everything. Like we have everything we need. We just plug it into the formula. Okay. So what's our first term? It's a. It's 3, right? And now we're going to do 1 minus the common ratio, which we've already figured out is 3, to the power of n, which is the number of terms, which we've decided is 10, divided by 1 minus the common ratio, which is 3. Okay. So let's solve this. Okay. So if we get out our calculators, so 3 to the power of 10, 1 minus 3 to the power of 10 times 3 divided by negative 2 is going to be 88,572. So as you can see, a very large number. They start stacking up very quickly. You know, if you want more examples or more practice problems with this, again, I suggest checking out Khan Academy, where they have a bunch of videos dedicated to geometric series. Thanks for watching, guys. Today we tackled factorization and geometric series. Next video or next few videos, I'll be talking about polynomial division. Yeah, so again, thanks for watching. Peace.